I believe I'm live. Okay, so hello everyone. I hope I'm both audible and you can see my screen as well, right? And cool. If you can hear me and if you can see the screen properly, do give me a thumbs up in the chat section. Great, hello. Do let me know if I'm perfectly audible to everyone and if my screen is also visible to everyone. Okay, breaking sound. Just a minute. Let's see what is the problem. Okay, just a minute. Is my sound better now? Or some background disturbance? Just a minute. If the sound is clear now. Okay, so if my voice is okay, if my voice is clear now, I hope it should be clear at this moment. Is everything clear now? Hello? Great, great, great. I feel like my voice is better now. I don't know what is the problem. I mean, hello. Okay, just give me a moment, guys. Okay, hello. Yeah. So, is it fine now? Yes, sorry for this disturbance. I don't know why it is happening today. Yesterday it was perfectly fine. Okay, cool. I believe there is no more disturbance in the background now. Yeah, cool. Good to start now? Sure. Okay, let me also try by removing my headsets. Is it something clear? ठीक है, sounds good. So let's start right then, right? If you come across any such disturbance again, do let me know, right? I'll probably do something. Chalo, cool. Sorry about this disturbance. So yeah, already we have wasted some time, but yeah, that's not an issue. Quickly, I am hoping that some of you or most of you have joined yesterday's session or day before yesterday's session as well, right? Wherein we first of all discussed about basics of C++ or different introduction to C++. Then we jumped into looking like for loops, any while loops, do while loops, different types of these things. And then we discussed about patterns, right? How can we print different number of patterns or different different kinds of pattern, wherein I tried giving you a kind of a skeletal formula, and I told you how we can modify that formula, that template or skeletal, those two nested for loops, and according to that, what are these 2-3 steps which you can use to make any kind of pattern, right? So that was about yesterday, right? Now for today's session, what we have is okay, I think my voice is too loud, right? Okay, just a minute. Let's do one thing. Let's try to reduce it. Yeah, or maybe I'm speaking too loud. Right? Is it fine, everyone? The volume level. So sorry about these disturbance. I think my headset just got broke, right? That is why we are facing this issue today. Don't worry, I'll be fixing this for the next class. Okay? Yeah, cool. So today what we are discussing is, just a minute, let's get started with it. And yeah, cool. So we have, just a minute, let's get it there. And today we have the concepts of function, right? And let's take another pen so that you can see it properly. Yeah, the concepts of functions, right? And the time complexities, right? Time complexity, maybe we'll also have a brief look about space complexity as well, right? So this is we will discuss. Let's move with the next point, and let's see what is we have in the index. Right, so obviously function we have to discuss, so we'll discuss what is a function, how do you create your functions, right, what is the syntax of creating a function and things like that. Then we will be looking at a second thing, that is called the call by values and the call by reference, right? What does call by value mean, what does call by reference means, and what is the basic difference between both of them. Then we'll be looking into time and space complexity, right? And pattern practicing, though we have done, right? We'll take some patterns at the end of the session, right? If we feel like doing anything, right? Although I believe if you have gone through the yesterday's sessions once again, you might be able to predict every pattern, how can we solve that, right? So let's quickly move in. Yeah, let's quickly move in and jump into seeing like what is a function. And basically we are focusing upon functions in C++ only, right? Although it is not like there is a C++ nahi, it's only function, right? Function can be used in any other programming language, but we are only concerned about C++ right now. So function may, first of all, let's see what is the function, right? What is the introduction of function? So suppose let's take an example ki maybe maybe I am doing some task, right? Maybe I am a worker, right? Let's take a scenario. I'm a worker at some cafe, right? And my employer or my head chef or my manager whatsoever, they call me and they say ki acha, you have to make a chai, right? Now you, or maybe a coffee, right? It depends upon your taste, right? Maybe you are a chai person or a coffee person. So maybe let's suppose that they tell me ki make a chai or make a coffee, and maybe I'm very new, or maybe I am not from this world, maybe, or maybe I am not from this whole globe. So what will I do? Maybe suppose I say, I don't know how to make a chai, or I don't know how to make a coffee, right? So what they will do is they'll say, you don't have to do much things. Suppose if you want to make chai, what you do? You boil the water, you put some those tea leaves, then you put milk over it. Then according to the need, you can add sugar over it, right? So these are like some basic features of making a chai, right? I mean, some basic steps of making a chai, right? So now suppose they told me this situation. I mean, they told me, this is things, or these are the steps that you do to make a chai, right? So suppose what happens is ki, okay, for one customer I have followed these steps and I made the chai, right? And suppose I am very dumb, right? I don't know, I generally can't remember things. So what will happen immediately after, just a minute, my chat got stuck. Yeah, let me reload that. Yeah, so immediately after, sorry, your voice is very loud and not clear. Okay, is it the scene right now also? I mean, I believe it was earlier, but yeah. Okay, so I'm saying ki suppose I tend to forget things quite oftenly. So what the manager will do, right? What my head chef or whatsoever, what they'll do is they'll write the instruction on one paper and they'll say, suppose if you want to make a chai, follow these instructions, right? Because they won't come at every time and they'll say ki, first of all boil the water, put some tea leaves, then put water, then put milk and etc. Right? So you can understand it this way ki if you are writing, okay, it's not clear again. What's the problem we are facing? What's the issue with that? Yeah, this thing is pissing me off. So any improvements? Can you hear me properly now? There is something pretty wrong with that. I don't know what is this. If my voice is something clear now, although yeah, thanks for the adjustment, yeah, okay. See, I'm really sorry about this thing again, because I don't know what strange thing is happening today. Yeah, I even turned off my fan, just in case maybe there is some disturbance from my fan in this scenario. Okay, anyways. Okay, that's so great to see the responses that you are ready to compromise or you are ready to adjust. But yeah, again, sorry for this, mess up that just happened. Anyways, I believe like it is somewhat clearer now, right? And you are able to hear me. And also one more thing is ki there is a delay, right? Suppose if I say something and if this thing is not here, I'll get this in a delay of like 15 to 20 seconds. So this is another problem that we have. Right. So now let's move ahead. Let's carry that. Right. So I was telling you कि maybe great. So the thing is that maybe someone or my manager or someone, they will write some steps in a page, right, and they will stick it in the kitchen area, right, so that every time I have to make a chai, or every time I have to make a particular recipe, what I'll do is I'll follow those steps, right. Instead of that person again telling me the same step, they'll write it somewhere and they'll stick it there, right. So whenever I have to make a chai, what I'll do, I'll refer to this piece of code, right. So similar thing is what we call functions, right, in C++ or in any other language, right. So function are, if I go about the definition of functions, right. So if I go about definition of functions ka definition is just a minute, let's remove that. Yeah, it is function is a block of code which only runs when it is called, right. I mean, what is it is saying is, yeah, block of code bole so it's just like a parchi, right. It's just like a chip that someone has written here, and only when I have to make a chai, or only when I have to make a specific dish, then only I'll refer to it, right. Instead of doing or speaking these things again and again, we have written it somewhere, and whenever I need this, I'll refer to this, right. It's that simple, right. So this is about function, right. Now you will say, what is the use of function, right. Why do we need functions? Why do we need to write it on a paper? We can tell it every time, right. So again, I think it is very obvious. Why will you tell this again and again if this thing is very simple, or this thing is very repetitive? There is no need of telling this again and again. The manager will get what do you say? The manager will will not be able to tell this every time. Okay, so that is why we'll make a section which will follow, which will have these steps, right? So now, okay, if this is the step, now just a minute, let's go back and let's see key. Yeah, right. So when we are talking about want to perform any task again and again, that time is considered just calling function name. Exactly, man. Yes, Ganesh, you are absolutely right. This is what function is. Now, if we have idea about it, now let's try to see the syntax of function, right? I'll directly jump into the demonstration. Yeah. Directly jump into the demonstration so that I can explain all these things. Meanwhile, as we move on, right, I'll remove all these things because these are not required. Now, suppose I want to print, maybe I want to print, or maybe I want to, I want to just print the square of any number, right? I want to say like square of 2 is what? Quickly tell me, what is the square of 2? One thing I can do is, I can do 2 into 2, right? Or maybe I can directly write 4 because I know that the square of 2 is 4. So I'll quickly write it, and now you can see that that's hello world we have written. No? We need to remove it because we don't need it at this moment. And what I'll do, I'll quickly run it, and then you can see what is the problem. There is some problem. I don't know what just happened. No, it is not running. Let's stop it. Yeah, cool. Right. Now it is saying that the square of 2 is 4. Right. Now what if I have to print the square of 10? What if I have to print nice please sir. Okay, sorry again man, Subodh. I don't know what is happening, what is wrong with this mic now. I even tried removing my mic. Again, there is some disturbance anyhow, I don't know. What's the problem? Right, I hope at least you are able to comprehend what I am saying. So please bear with me. I'm so sorry again and again. I'm extremely sorry for this voice mess up thing. Right, now what I'm trying to say here is, suppose if you want to print the square root, I mean if you want to print the square of maybe 10 now, right, or maybe let's take a tricky number. Let's say, oh sorry, I need to zoom in also so that you are able to see what I'm writing. Maybe let's write a square of 39, right? I'm guessing you guys are not aware about the square of 39, right? Unless and until you You be able to hear it. Cool. So unless and until you put on your calculators and if you run it, right? So now if I want to print the square of 39, right? What will happen? I'll write the same code again and I'll run it, and now you'll see the square root of the square of 39 is 1521, right? So again, suppose if I have to print if I have to print the square of like 10, 20, 30 numbers, right? 10, 20, 30 different numbers, and if I write all these statements again and again, this will be a problem, right? Although in this situation, you will say we are only writing one statement, right? We are only just writing one statement, the square of this is that and that. But the problem is we don't have to write it again and again. What we can do is we can modularize it, right? We can write a thing instead of it. What we can say is, we can say, just a minute, I will say that function, and then I'll say square, and I'll write this thing here, and I'll do it, right? And I'll simply call the square over here now. Right now, let's see if there is any change or not. Sorry. Oh, sorry about this thing, right? See, the problem that is happening because is sorry. See, I generally am coding in JavaScript and Java these days, right? So in JavaScript, you write a function over here. So sorry about this mix-up thing. Sorry. Yeah, now you can see that instead of writing that cout statement, what we have done is we have written a function of it, right? We have given this a name of square, and if we are calling it, right, if we are just saying call this function over here, so then this function is printing the same thing, right? You can see the output is again the same, right? Now there might be confusion for some of you who are joining, who are hearing this word function and who are seeing this syntax for the first time, right? Let me clear that first, right? So there can be two parts, right? The first part could be you are defining a function or you are declaring a function, right? Or maybe your definition of the function. Right, definition of the function means you are giving the definition. Yes, you are basically pasting the chit and you are writing the instruction in that chit, right? Yes, this is how you make a chai, right? You write over it, and then what you do, you write boil water, put tea leaves, etc. Right? So this is the definition of a function, right? And whenever you are writing a function, you have to make sure that, just a minute, let me write the syntax as well. Syntax of function, right? So syntax of function means the first thing that you do is you write a return type. Then you write what? Name. Then you write these columns, and inside this, or let's do it this way only, right? Inside this, you write the statements, right? So this is the basic syntax of writing a function, right? So the return type, now you'll ask, so what is the return type, right? Return type means what the function will return to us, right? Returning means see, suppose if your function does any calculation, right? If it calculates some square or something, and if you want to get that value out of that function, how will you get that function? And how do you get that value? You get that by giving a return type. Now, void is one such return type. Void means the function is not returning anything to us, right? And we will see different examples, like we'll see what will happen if we write int here, right? What will be the difference over that, right? We'll also do that. But for now, let's understand the void means the function is not returning something, it is doing some task, right? But if you look at it very closely, this is of no use, right? Why no use? Because if you write this function, this will always give us a square of 2, but we don't want a square of 2 at every time, right? We want, if I give you 10, if I give you 20, if I give you 400, if I give you like any different number, you should give me the square of that number, right? So how is that possible? So that is possible with one thing that we call as arguments, or maybe you can call it as parameters. There is a difference between arguments and parameters. Let's call it as a parameter for this moment. Right, parameters you can give. Parameters maybe whenever you are giving parameters, you have to make sure that you write the data type and then you give the parameter, right? Data type बोले तो I mean what kind of parameter you are passing, right? You can pass a integer type parameter, you can pass a character type parameter, you can pass different types of parameter like boolean parameter and all, right? So that you have to specify, right? So let's modify it a bit and let's see what if I want to print. Maybe if I give I am giving you a number, right? Suppose n is the number that I am giving you, and I want you to give me just a minute, and I want you to give me the square of that number only, right? Now everyone, are you able to comprehend what I am writing here? I am writing here is I will give you a number n, and instead of showing me the square of 2 every time, I want the function to show me the square of n. Yeah. And also, if you are, liking it, if you are understanding anything at this point, and if you are enjoying something, right, apart from that voice disturbance, which I am extremely sorry about, so you can consider liking this video, and you can subscribe to the channel, right, obviously, and you can share it with your friends as well. There is some bootcamp going on for data structures and algorithm with C++, right? They can also hop in. So now let's see what will be the answer for that, right? And obviously, when I'm writing over here, suppose if I say 4 over this time, right? Again, don't worry, I'll explain what I'm writing and what is this. Now, can you see a difference over here, right? Just a moment, for a moment, let's just comment out this line. And let's see if there is a difference or not, right? Can you see the difference? The difference is now instead of every time receiving the square of 2, what we are receiving is, we are receiving the square of 4, right? Which is 16. So how is this possible? This is possible by passing some arguments, right? Now see, at different moments, sometimes I'm using a parameter, sometimes I'm using an argument, right? So at this point, you can understand the parameters and arguments are somewhat like the same, right? These are the values that we pass to the function, right? So I'm writing over here, I will pass you a number, I will pass you a variable that is called n, and what you will do is you will give me the result, or you will print the result of n times n, right? Okay, now if I want to replicate this multiple times, if I want to say, now I don't want a square of 4, now I want a square of 16 itself, right? Or maybe it's 15, right? So what will happen if I run this? Again, it is working for 16 as well, right? So the key over here is if you want to get the custom inputs, right? If you want to get the custom output according to your custom inputs, how you can get that? You can get that by defining those arguments and parameters, right? Now there is a very minute difference between arguments and parameters, right? So parameter means whenever you are defining your function, right? Here you are defining your function, right? You are saying, yes, so there is a function called square, and this will print this value for you, and this will have a void data type, this will take this value from you. So this is the definition part. So in definition, what you do is you pass the parameters, right? You write all the values that you give here are parameters. And whenever you are calling this function, right, this is by the way called as calling a function, right? And in this situation, what you are doing is you are passing the arguments, right? Everyone, are you clear with this point? I know that I have told too many things and I have showed, I went a little pacer. But again, are you able to comprehend what is happening and why this writing this in is giving us that answer? I hope everyone is getting it, right? If you come across any doubt, you can ask in the chat section and I'll answer. Right. So this sounds cool. Okay, we are able to do it. But what if I don't want to print it, right? I don't want to print the line or print this thing in that way. But if I want to collect that answer, right? I don't want this to just print over here. So in that scenario, what I do is I write a return type over here, right? You can write int, you can write any other things, and in that part, whenever you are writing a return type over here, what we will do is we will if you have written any return type over here, you have to return that value, right? How do you return a value? You return a value by writing a return, and then maybe you can say simply n times n. Right, this is one way. Or if you want to write it in a modular way, or if you want to write it in a simpler way, you can say that let's call int square, or maybe let's call it int temp as n times n. Right, let's do this. let's call this thing first, and then once we have the answer in our temp variable, what we'll do is we'll return the temp, right? Again, why is this coming? Cool, right? Now let's see what will happen, right? Again, let me tell you something terrible is going to happen, right? This will not work exactly. Let's do one thing. Just a minute. Yeah. Okay. So something terrible is going to happen. I was telling you this. Now you can see that nothing is getting printed over here, right? Why it is not getting printed over here? Because first of all, we have removed the cout statement, right? And second thing is, if we are returning something from here, what we can do is we can collect it in a variable. Maybe let's call it a, right? And let's collect the answer first, and let's see if we try to print, if we try to cout a, what will happen? Right? Let's do one thing, and boom! Right now you can see that 16 is getting printed over here. Right. Why is 16 getting printed? Because we have collected the value of square of 4, which is 16, in variable a, and then we are printing that variable, right? Again, let's try to collect that next value in another variable. Let's call it a b, right? And again, let's try to print that variable. Let's say cout b. Cool. Now you can see that 16 and 225 are coming over here. If you want to try it with any random number, like let's give it 89, right? Let's see what is the square of 89. If I run with this, boom, right? The square of 89 is 7921, and that is why we are receiving over this. Right. So I hope the syntax of functions and the what are the different return type, what it is, how do we collect the return type, and what are the different ways of writing a function is also clear. Okay, someone is saying a white is still not clear. Okay, what is the issue with that? Just a minute. Okay, so I hope there might be some improvement. I don't know what is happening. I'm just trying everything from my end, but yeah, anyways, so sorry about that. At least are you able to understand what I explained about functions? Yeah, this though I feel like if I see, I have increased the suppression level, right? Or maybe I have decreased it. I feel like there would be much disturbance in this scenario. Kindly confirm this once. If my voice is better in this way, or it was better in this scenario, right? When it is in 0, or when it is in this. When it was, yeah. Okay, is it clear in this way? Like when I have. Okay, cool. I should have done this earlier. Great. Chalo. So cool then. If this is clear. Now what I was telling is, let me quickly summarize it. Although I told na ki this will be problem. Oh man, what is the problem behind this? I'm so pissed off right now. Okay, just a minute, guys, just give me a minute, let me try something. Microphone to are not connected. Go to audio input. audio input, where are the audio inputs? Just a minute. Although mic is not connected, but it is showing the mics option. I believe my voice is not you cannot hear my voice now, right? Or can you? I mean, you can hear. Okay, chalo, let's continue with this thing. I tried everything and this is still not working. Might be some problem with the let's do one thing. This is the last option that I have, right? I cannot do anything else after this. Let's connect with my wireless earphones. So sorry about this. Just give me a minute, guys. Just give me a minute. I'm connecting with my wireless earphones now. Cool. So is it, I mean, is there any improvement now? Any improvement? No, it's fine. Cool. Let's continue it this way now. Alright, what is the problem here? This. Chalo, okay. Let's continue it this way. I should have checked all these things before joining. Sure. So yeah, I was telling about ki I was telling you what is the syntax of the function. Even before knowing the function, the syntax of function, there is something called as a definition of a function and calling of a function, right? So consider it this way: ki whenever you are yeah, I think it is cool now. Okay, so consider it this way: whenever you are maybe writing a cheat, right, or maybe you are writing a cheat sheet, the first thing is you are defining the cheat, right? Write those type, and after that this, right? The second thing is whenever you need that sheet, or maybe whenever you need that sheet, what do? You take that sheet or you look into that sheet, right? So this what we are doing over here is the definition of a function, right? Definition of a function is this. We are defining what this function will do for us. Second thing is we are calling a function over here, right? You can see like we have called a square function over here, right? Similarly, we have called the same function over here as well, right? So this is the definition and the declaration, right? I mean the definition and the calling of the function. Now whenever we are defining a function, there is a particular way of defining that function. That is key. Just a minute here, I'm receiving some calls. Let me ignore that. Yeah, so whenever you are doing that thing, the first thing is you have to write the return type of the function, right? Return type bole to what the function will return to us, right? If the function is not returning anything to you, what you will do is you'll simply write a void over here, right? What you'll write void over here, as I have written in the earlier situation, right? But whenever you are writing a void now, you'll not be able to write this return statement. Just a minute. You'll not be able to write this return statement. This will throw an error. So if you just want to print something, or you just want to call it and just have some fun or something, you can call it a void function. But if you want to return something out of this function, you'll have to write an int or maybe a double or something, right? Now you will say how we will decide what should we write here, right? Should we write an int, should we write a double, should we write any other different data type, right? So that depends upon which kind of data you are returning. If you see in this example, I have initialized a variable called temp, right, which is an integer type variable. So if I'm returning that variable which is of an integer type, so I have to write an int variable over here, right? So if I define it as double and if I try to return it, it will not return, right? This will throw me an error. Okay, so maybe inside function whatever things you want to do, you can do, right? And after that your function is ready, the definition of your function is ready. One more thing that you can come across is maybe every time you don't want to print the same thing, right? You want to have some different things according to some different inputs, right? Maybe if I if I say this is the recipe for making 1 cup of tea. If I have to make 10 cup of tea, will I follow the same recipe? Will I add the same number of water? I mean, will I add the same quantity of water? Will I add the same quantity of tea leaves? No, right? What I'll have to do? I have to modify my recipe according to that, right? I have to change some of my steps according to that. So how will I do? I'll say maybe first of all get the number of people that you have to make chai for, or maybe that you have to make tea for. Right, so I'll get that number over here. Maybe let's say n is the total number of person, and in the steps what I will write, I'll write take n by 2 number of n by 2 glass of water, right, or maybe whatever is the proportion. So depending upon that, I'll make my recipe from the inputs, right? So how do you pass those inputs? You pass those inputs over here, right, after writing the name of this, right? And the first thing is you write the data type of what value you are providing, right? Since we are providing an integer n value, so that is why we have written int over here. Similarly, the next thing is you write the variable that is consisting the value. After that, this is simple thing, and we have returned the output, right? So now what I was saying is that whenever you are calling a function, so if you have given a data type, or if you have given a parameter to your function, you have to pass it whenever you are calling it. If you write it this way, right? Let's call it this way. Let's see if this works or not. If I'm running it this way, you'll see this will not run. This will give me an error, right? Why? Because I've said whenever I'll call a function, I'll give this a value. I'll give this some value to call upon, but I'm not giving it a value. So that is why it was throwing an error, right? So you have to give that value. Now there is one thing called arguments, and there is one thing called parameters. So parameters and arguments are almost the same. The only difference is that whenever you will call them the parameters of the function, right? And whenever you are calling that function, you will call them as your arguments, right? So this is about calling function. This is about syntax of function, and yeah, right? I hope this thing is clear by now, right? Now parameters and arguments I have already told, right? Now comes a very interesting part, that is call by value and call by reference, right? So let's quickly see this example, right? For an example, let's do one thing. Maybe I want to say, let's take a number. Let's say if we have int a, maybe int a as 10. Right, what we'll do is maybe we'll make another function. Maybe let's call it as x, right? Let's keep this aside because we don't need them right now, right? I'll comment it and I'll write what? I'll write int x equals to 10, and I'll say double the number, right? Int, or maybe let's call it a void double number, right? So what it will do is int a or int x, whatever we'll write here. Now we'll say it will do one thing. It will say x equals to x times 2, right? I hope you are able to understand what I am writing over here. I'm just writing we will give you a number and you have to double that number, right? How will you double that number? You will double that number by multiplying it with 2, right? It's that simple. So now if I call the same function over here, if I write double number and if I give 10 or if I just give x over here, right? Now what is the value of x? The value of x is 10, right? And if I again try to print the value of x over here, what will happen? Let's see. What should happen according to your according to your understanding? Yeah, sorry for the audio problem. I'm so sorry because I don't know what just happened with my microphone or headphone. Right. The main thing is are you able to are you learning something or not, right? These kinds of problem are secondary, right? And I hope I'm making these things understandable to you. Yeah, attendance you will get at the end of the session, don't worry. We'll quickly wrap this up. Take it. So yeah, what should happen? Quickly tell me the answers. Chalo, if you are not telling me the answers, let's try this and let's see what should be the answer. Boom. Now you can see, okay, some smart people are there, right? They are saying 10 is the answer, right? But I should get 20 according to me, right? See, what I did, I told I'll pass you a number and you have to double that number, right? Now, according to this normal understanding, this should get double, right? This should print 20, but why it is still printing 10? Right, so it is printing 10 because some of you might have guessed it. key, because we have passed it by value. Passing it by value means key, suppose if we are giving any value to it, right, it will make a separate copy of it. Let me show you this, right, and let me understand, and let me make sure that you understand this with the help of an example. I'm saying you this ki, achha, there is a box or there is a variable with a value of x, right? I'm saying you double it, right? So by doubling it, there is some particular machine, double machine this is called, you can say double machine. What it will do is you will pass a variable from here and it will give the doubled output of it, right? But the problem is key, if you are printing that, I mean if you are doubling that number, you are not exactly doubling the exact number. What you are doing is you are passing a copy of that number. You are saying, acha, copy this variable first. I have copied it, right? Pass it through the machine. The number will be 10. I mean the number will be 20. But again, if you are printing this x over here, now you are not making use of this anytime. You are only printing this variable. So this variable is not changed because a copy of that variable was made and the copy of that variable was doubled to 20, right? I hope everyone is clear. Now let's see one thing. If we do one thing, if we do pick one thing, maybe you will say, acha, maybe there is something wrong with our code. So let's try printing x over here. Let's see if we get, and let's write the intel over here, and let's see if we can see 20 or not. Right, now we can see 20 is getting printed, right? 20 is printing from this function, right? So that means the number was getting doubled, but the problem is that double number was a copy of this existing number, right? So this is what we call by value, right? We are just calling, we are just creating a copy of that and we are just calling it, right? So the original value will not be changed. Now instead of doing this, what if I say, just a minute, what if I say key, I'll write s% over here. Where did it mean? Right, let me quickly show you the example, I mean the syntax of it first of all, so that you understand. Yeah, function call by value, the original value is not modified, right? You have seen this example. We are just passing that value and it is not giving us any suitable example, right? Now calling by reference will mean we will not pass the copy of that. Instead what we will do is we'll pass the address of that value, right? We will say, this is the address where is the original value exists. Now change that value, right? So how will we do that? We will say, this is the example. So I'll say star over here means the what do you say? The pointer, right? Although this you might not know at this point. And see, whenever I write s%x, right, s%x will mean that I am passing the address of x, right? S% means the address of that, right? You can see that we have passed s% of x and we have passed x% of y over here. This is a relatively complex example, which is why that is why I am not taking it here. Now what we'll do, we'll say yeah, exactly, using as per sign, right? So what we'll say key in that value, what you do again, you can write it this way only, write 2 times the value, and let's see if this works or not. Okay, so there is some problem. Acha, the problem says ki acha, we will write as percent star x equals to 2 times of star x. That means, yeah, expected primary in the function double value. Just a minute, function expected primary expression before, sorry, there's a difference between star x and x star. Boom. Now there is some problem, right? What the problem is, you can see that we are receiving some weird thing, right? So what is that thing? If you look at closely, there is some hexadecimal thing, right? That means we are getting the address of that, right? Why we are getting the address of that? Because we are trying to print what? We are trying to print x, not value x of x, right? So if we write this over here, then hopefully we should get 20, right? Why we are getting 20? Because star x means the value at x, right? And as percent x or simple x means the address of that, right? So I hope this thing is clear. Now you can see both ways we are getting 20, right? If I comment out this thing and if I only print the value of 10 after that, now you can see we are receiving 20, right? So this is the difference between passing by values and passing by references, right? References means that you are using the address of that, right? So in this situation, let me quickly let me quickly explain with the help of the demonstration. That is, it will mean, just a minute, let's take another colors. Let's say this one. So this was by value, we are passing by value, and this by reference. Now what we are doing is, if this is the value, right, if this is x, what we are doing is we are passing this exact value through the double machine, and what we will do is it will make this value 20, right? I hope the difference is clear by everyone now. Okay, so this was about the reference and calling by values. Now let's move on and let's see. Okay, C++ switch statement. I feel like this is already done, right? We have done that in the last class. Switch cases, how we do that, right? Although if you want to write particular statements over here, you can write instead of writing just one statement that we were writing in the last class, right? So this is not explaining again because this is already done. Now we have another thing. I mean, this is the the technical difference between the call by value and call by reference. See, if we have already done that, but quickly let's have a look over it. Whatever it is saying is. So it is saying that okay, call by value the value of function is passed. I mean, a copy of function will be passed, right? And the address of the function will be passed. I mean, the whole variable will be passed instead of passing a copy of that, right? Again, it is very obvious that changes made to that copy will not be reflected to the original copy, right? Again, the vice versa will happen here. And actual and formal parameters are created in the memory location. I mean, see, actual and formal means different variables of that. I mean, one will be that and one will be a copy of that, right? You can say this is an actual parameter and the copy of that you can call as a formal parameter, right? In this situation, both will be same. Why both will be same? Because again, they are pointing to the same memory address, right? So if this was the x, we'll say pass this value only, right? Don't create any other value or don't create any other variable. Right, so this is about the passing by value and passing by references. Now, I hope everyone is clear to this point. Everyone, okay? So quickly ask if you have any doubts, and then we'll move to the interesting part, the very interesting part, that is about the complexity. Yeah, right. Sorry about that thing. Everyone, now we clear to this point. Call by value and call by references and functions and its declaration, things like that. Right, I'm hoping everyone is clear. If you have any doubts, do drop them in the chat section and I'll take them later. Right, now let's move to the last and important part of today's session, that is the time complexity or the space complexity of your program, right? So suppose if you are writing any function or if you are writing any code, right, and maybe if your function or if your code is not optimized by what I mean is, suppose if you are trying to print the square of any number, right, if you are trying to find any particular operation, and if your program takes 10 seconds for the same input, and if my program takes 1 second for the same input, right? So what do you think? Whose program is more efficient? My program will be efficient, right? Because my program is able to do that same thing. My program is able to do that same thing in a relatively lesser time, right? Now you say, this might be possible because I might be using a high-end system, or you might be using a poor configured system. But we are not considering the fact that if the processor is slow, if the processor is fast or not, right? We are only considering if we run both the programs in one similar machine and if we give similar number of inputs, right? Similar number of input means suppose if I say find maybe just do a calculation for a simpler number, right? And if I say I'll do the simpler calculation and your program will do the complex calculation, right? We are not doing that thing. We are saying we will run the program on the same machine, we will do the same calculation on both of the program, and then we will check which program takes much time, right? So this thing is basically the time complexity of your program, right? That means if your program can handle the same inputs on the same machine on a relatively lower time, or it will take a larger time, right? Exactly. So now you say, Acha, what is the importance of that, right? Again, whenever we are dealing with codes or whenever we are doing such things, we need to make sure that we are writing the efficient code, right? Why efficient code? Because if I say suppose what will happen if I say Acha, you open your calculator and if you try 10 plus 10, right, and if your calculator will take 10 seconds to give the answer as 20, right, so that will be very annoying to do, right? Instead of that, what you like Acha, immediately I write 10 plus 10 and you will get the answer at the fastest time, right? So this is why, I mean, this is a very simple example. Let's say the calculator does not take much time, right? Because the inputs are very low, the complex, the computations are very low, right? In high-end secure systems or whenever we are dealing with so many data, that minor thing will make a very huge difference, right? So that is basically time complexity. And now let's see what is the time complexity? How do you understand what is the time complexity of anything, and what do different time complexity mean to us, right? So if you look at this table closely, just a minute, let's go to that slide. Yeah, if you look at this so if you look at this thing very closely, you will find out that there is one thing called O of 1, right? Even before going to any of the time complexity, there is one thing called big O, right? Or maybe they simply call O. So big O or O will mean that what is the maximum time this program will take, right? Again, I am not going into how do you calculate this, how do you calculate log n, how do you calculate O1, or how do you calculate this thing, right? I am not going into this part because this is not needed at this point. I am just telling you what could be the complexity, right? And how do you calculate, or how do you say what is the time complexity of any program? Suppose for an example, let's say I am giving you a particular number. I am saying let's talk about the square program. I am saying there is 4. Give me the square of 4, right? You will say immediately 4 times 4 will be the square. If I say 169, give me the square of that, right? You will say what? 169 times 169, right? Maybe if I say 7,000 or something, right, very big number, then you will say that number times that number, right? So can you imagine in this situation, will it matter if I give any larger number or if I give any smaller number, right? Will it matter to our time complexity or not? I mean, in general cases. See, in all these situations, every time we are doing one complex operation only, right, or one simple operation, that is multiplying. So even if we multiply 4 times 4, even if we multiply 169 times 160 times, it will not take much of the difference, right? I mean, it will not make much of the difference. But what will happen if I say, just a minute, there is one array, right? Array, you might not be able to understand at this moment, but yeah, it is group of some variables, right? If I am saying, we have to add 1, 2, 3 and 4, right? This is one situation, add all these 4 numbers. And at the next step, what I am saying is, there is one, and until 1000 you have to add all these numbers, right? So will this make a difference or not, right? Adding 4 numbers in a series and adding 1000 numbers in a series, will this make a difference or not? Obviously we will say there might be a difference, right? 4 numbers will be added very fastly and 1000 number will take a much of time. But again, I'm not saying not saying about the digits, right? I'm just saying if you have the calculation that you are doing is dependent upon the numbers that will make the difference, right? So the thing is if you are able to do all these calculations in a constant time, right, then at this scenario the time complexity will be of O of 1, right? Big O of 1 or O of 1, that will mean you are able to do that in a constant time, right? Now all these differentiation we will see when we look into the code and we will check their time complexity, right? Suppose if you let's see what this says and then we'll move to the next slide. That is says in case of addition of 2 bit numbers, n step are taken, right? Consecutively the total computation will become c times of n, right? Suppose if you are adding suppose if 1 plus 2 will take some constant time for us, like suppose adding 2 numbers will take 1 second for us. So if we add 2 numbers, it will take 2 times of 1 second. If we add 1000 second, what will it take? It will take 2 times of 1000 times of 1, right? So in all these situations you can see that the number is constant, right? What the number is constant, 1 is constant, so I can say c times of n, right? So if the number is constant, if we say we have to we have to add some numbers, the time complexity will not make much of the difference, right? But if we have different arrays, right, then it will make the difference, right? So I hope this should be clear. Now let's move on and let's see how do we calculate the time complexity with the help of one example. Right, I'll quickly wrap this up, don't worry about that. And even before going into that, there is something called as a space complexity, right? Space complexity means, suppose if your program is making use of some variables, right? Maybe suppose there is one variable, right? Suppose if you are adding, right? Let's take this example. So whenever you add, what do? You take another variable, temp, and you take two variable and you add those variables and you put these values in that variable, right? So every time if you add 1000 number, if you type 2000 numbers, you will only take one constant space, right? You will not create any array or you will not create any extra baggage. Alright, so in that situation, if you are not using any multiple arrays or if you are not using any much of the space, then your space complexity is constant, right? Right now we are not going into much of the detail in space complexity because we are only focused on the time complexity, right? Let's move with the next slide and let's see what are definite, how can you judge what is the time complexity of this, right? So in this situation, let's tackle this example and let's see. Right, now we can see there are two nested loops, right? One loop is there, then inside this there is another loop, right? Now quickly tell me this, we are moving from 0 till n, right? Suppose for a moment, let's say n is not movers, right? Let's say we are going from 0 until n times, right? And what will be the time complexity of that? Time complexity of that will be O of n, right? Y of n, because the n is not defined to us. N can be anything, right? If I only say we have 5 numbers to add, then it would be big O of 1. Why? Because 5 numbers is a constant number, right? Anytime if you add 5 numbers, the complexity will be remain the same, right? And if you add different numbers, then according to that number you will have the time complexity. Now if I just go through n numbers, the complexity will become O of n, right? But what if I'll have another nested loop inside that? What will happen is, see, for every one number, let's tackle this in this way. You have 1, 2, 3 up till n, right? For every one number, just a minute, yeah. For every this number, what you will take? You will say there are other such n numbers, right? You can see for every I, we are going till n. Similarly, starting from j, we are going till n. Again, you do all these operations for 1, then you move on, you go to 2, and then again you do all these operations for 2. Again, until n you do the same steps, right? So, can I say that we are doing n operations, right? For the outer loop, we are doing n operation. For the inside loop, we are also doing the n operation. So, can we call it as big O of n times n? Why? Because suppose if I have to do all these operations for 2 times only, right? So what can I say? I can say 2 times of n. If I have to do these for 3 numbers, what can I say? 3 times n, right? But what I am doing is I am doing these operations for n numbers. So I can easily say that n times n I am doing. So effectively the time complexity of this code will become n square, right? I hope you are able to understand why the time complexity became n square in this situation. Right, again let's see what are the charts saying in. So should want to put for this. Okay, so Shireen is asking count precision to see out. Okay, that is about the precision, right? So I believe see out precision. I think the syntax is not correct, right? Shireen, whatsoever. Yeah, Shireen, the syntax is not correct. Yeah. Yeah, okay, ठीक है. चलो. Now, okay, just a minute. What are the chat saying? Cool. I think we can. Yeah, n. Okay, can you explain n square? N square. This is n square. I mean, whenever you write n2, just a minute. N2 is nothing, but n square is something, right? So I think this is what you are getting confused with. N square. And let me quickly do that again. Just a minute. Chalo, let me quickly do that again. See, what I'm saying is कि you have this number starting from 1 until n, right? Now, if you say कि I have some numbers, if I have like 5 numbers only, what can I say? If counting or if doing operation takes 1 second for one number, I can say the operation will take 5 times of 1 second for me, right, to complete it. So can I say this is constant? Why constant? Because the number is constant, right? If suppose I say I have n numbers, so counting one thing or doing one operation for one number takes 1 second, so doing this similar operation for n numbers will take 1 times n, or simply n complexity will be there, right? So this is why I am saying writing this for loop will take n complexity. Again, since when we write nested loop, what we do? We say if we have 1, 2, 3, etc., until n, and again, if you remember from the last loops concept, if we write a nested loop, what we'll do? We go to first number and then we'll write the same loop again, right? From 1 till, from 0 till n. So again, there will be loop from 0 till n again. So you will do all these calculations for this number again, right? So you can say, acha, n operation you will do for 1. Again, you move to the next number, that is 2. You again do all these operations for this number again. So if you have reached 1 and 2, you can say you have already done 2 times of n operation. Again, if you reach 3, you can say you have done 3 times of n operation, right? So if I do all these n operation, can I not say I have done n times of n operation? N times of n operation is similarly n square operations, right? So similarly in this situation, the complexity will be n square, right? Sure, cool. Now let's move to the next part, which is a very interesting one, right? This will involve some mathematics, right? So let's see this one. In this situation, you can see that we are starting from maybe n, and what we are doing is we are dividing that number by 2 every time, right? And what should be the complexity according to you, right? Let's let's tackle this with an example. Let's see for the first case what will happen. Suppose if we have maybe for the first case we'll have n, and what we'll do is we'll n by 2 this, right? For first case we'll do n by 2, and this next step what we'll do, suppose n is not known, right? What you will do is you'll again do n by 2 of this existing number, right? You have n by 2, then you again do n by 2 of that. What will this become effectively? Will not this become n by 4 times? If you have n by 2 and again you are doing n by 2 of, again you are doing 1 by 2 of that, will not this become n by 4, right? Again, if we take this for a further step, for the next round what will happen? We have n by 4, and again if you are doing half of that, will not this become n by 8? I hope you are getting, right? This is simple mathematics. Again, if you take this to the next level, n by 8 you have, if you have already, and if you are again doing half of that, will not this become n by what? Sorry, n by 16, right? So going through this pattern, we can clearly understand, just a minute, we can clearly understand that every step may, what effectively is happening, we'll start with n by 2, then we'll move with n by 4, then with n by 8, then with n by 16, right? If you look at these patterns, these are nothing but 2 to the power some steps, right? Let's k step, right? Why I'm taking k step? Because until which point this will run? It will run until this becomes non-zero, right? Suppose at first step it is 2, 1, then 2 to the power 2, then 2 to the power 3, right? Let's take at n step, let's take at kth step, this becomes 0, right? Why we are taking until 0? Because until this situation satisfies, right? Until you have a 0 value where this loop will run, right? So let's say we will run this until what? Or maybe we'll say we'll run this until n by this will become us, right? Now if we take this, this will be until this will be greater than equals to 0, right? We'll be running this till then. Now if I do simple linear inequalities on that, what I'll do is I'll do it this way. I'll say 2 to the power k, right? This is again mathematics. Or let me do that in separate notepad. So let's complete it here, then I'll maybe have it in a next pad. So if I do this and if I take log on both sides, right? If I take log on both sides, what will happen? Log base 2 if I take on both sides, can I say that log base n this will become, and this will become what? Simple k, right? So can I say that this execution will be done, in what step? In k step, that is in log 2 by n steps, will reach this point. So if we have like log 2 n step, if we'll take log 2 n steps to reach there, will not this time complexity will become 2, log 2 base of n. Right, I hope you have got this. If you have not got this, maybe there is something, maybe you need to revise some of the maths. Right, don't worry, I'll write this in notepad. I know this is something messy over here. I'll take quickly 1 or 2 more minutes and then we'll wrap up this. Right. No, n by 2 complexity will not be there, right? So one more thing I want to clear over here is, see, if the complexity is n by 2, maybe if the complexity is n by 3 or something, right? We will discard this constant variable. Why will we discard this? Suppose if you are taking any constant now, this will not matter. We'll only take this variable, right? If it would be n by 2, it would be n by 3 or something, then we'll only write as n complexity. Right, and I hope this mathematical calculation or this proof, is something satisfiable, right? You are able to understand why this is log n, not n by 2. Chalo. So the similar will happen when we will have, just a minute, suppose if we have, instead of n by 2, if we have or if for I by 2, if we start from 1 and if we do I equals to I times 2, na? If you do the same logic again, you will find out the term complexity will be log 2 base n in this case also, right? If you try this, let's try, you will try this after this session and you will find out this will be log 2 base n, right? So now quickly move to the next point, and which is our last question for now. And yeah, chalo, let's see. Yeah, let's clear this. And this is a very simpler one, right? Why it is simpler? Because all these things which are required for us to solve this, we have already done. Now if you see this example, right, first of all let's tackle the inner loop, right? In inner loop, what is effectively happening? We are starting from 1, we'll go until n, and at every step what we are doing is we are doing 2 times the number, right? So I told you, if we are dividing the existing number by 2, right, or if we are multiplying the existing number with 2, in this situation what will happen? The time complexity will come out to be log 2 base n. I have given a mathematical proof of that. Don't worry, I'll give this again. But at this point, let's understand ki, if we are multiplying the number by 2 or if we are dividing the number by 2 at every step, what will happen? The complexity will come out to be log 2n, log 2 base n. Right, so inner thing is clear, right? Under ke loop ka we know ki this will come out to be log 2n. Let's look at the outer loop now. Now you can say that we are starting from n by 2, right? And we are only going till n, and at every step we are only incrementing by 1 step, right? So for a moment let's not include this n by 2, right? Because suppose if I say ki you have numbers from 1 till 50, and instead of counting the numbers from 1 to 25, you directly start from 20 to 50. Will this make a significant difference or not? Whenever we are talking about general numbers, we ignore these constant value, right? We ignore if the number is n, if the number is 2n, if the number is n by 2, if the number is n by 4, right? So in that situation, what will happen? This will again come out to be O of n. Why O of n? Because numbers are increasing linearly only. So if we combine all of them, how do we combine all of them? For each number, what we will do, we'll do log 2n steps of this. So can I not say that the time complexity of that will become log 2 base of n? Right. So this is the answer of this code scenario. The time complexity will become this only. Right. So this is about the time complexity. I have defined 1-2 example of that. Right. And just a minute. What is this and why it appeared? Right, so this is about today's class, where we discussed functions, we discussed about different time complexity, and yeah, don't worry, I'll explain the mathematical proof just in a while for those of you who didn't got it properly. And by the way, it's a wrap of the session. And if you enjoyed anything, I'm sorry again for the disturbance, and sorry again for the mess up that happened in a while. I'll definitely keep this in mind, and we'll definitely keep this in mind for the next session, and that will be a smooth and flawless session, right? Don't worry about that. But I hope you have got something, right? At least not everything, but at least something you might have got. right, about everything. And if you come across any doubt, if you have any doubts in suggestion, you can tell that in the feedback form also. I think someone from the team might have sent the attendance link also. Okay, now quickly let me make sure that everyone here knows the proof. So I'll quickly do this once again, and then we are wrapping up this session. What I'll do is, chalo, let's start from here. I was saying, okay, if we are starting from 1, right, if I is 1, and what we are doing is, at every step we are doing is I equals to I times 2, or maybe I equals to I times n. Maybe let's start from n, and let's say we are, just a minute, I equals to I by 2, right? And what at what step we will run? We will run until I is greater than equals to 0. Why? Because suppose if you try dividing any number, right, by 2, you'll have an end step, right? What will be the end step? When the number will become 0. If you try dividing it by 0 again and again, you'll ever receive 0. So that is why we'll stop until we reach this point. Right, now let's quickly look at this proof, and we'll wrap up the session. So what I'm saying is, now I don't know until, how many steps this will take, right? Reducing a number from n until 0, how many steps it will take. So can I say, for the first step, what will happen? First step, what will happen? The number will be divided by 2, right? And the next step, what will happen? Suppose I don't know, again I still don't know what is the number. So I'll say this number again will be divided by 2. So can I not say n by 2 is the number now? And if we divide this by 2, it's simple mathematics. This will turn out to be n by 4. Right? If we move to the next part, the third part, what will become? Effectively the number is n by 4 now. So if I again take this as a number and divide this by 2 again, what will become? It will become n by 8. Right? Again, if you repeat this step, you will notice that we are receiving n by 2. Then we are receiving n by 4, we are receiving n by 8, we are receiving n by 16. That means these values are going by the power of 2. Can I not say that, okay, at some step, let's take at nth step, or let's take at kth step, right? At kth step to the power of k, this number will be reduced at 0, right? Let's take this assumption for now. So what will happen? Can I say that, okay, we have to check that if this number is greater than equals to 0, then I condition, right? If this is 0, then we should stop. Now we have to calculate what is the value of k, right? In how many steps will be able to reach there. Suppose if I found out I will be able to reach that in 10 steps, I can say that the time complexity will become 10 times of the operation. So I'll again do the simple linear inequality here. I'll move a bit. Now I'll do the simple mathematics over here, and I'll do what? I'll write it in this way. I'll take this here and I'll write 2 to the power k. This is simple sign over here. Now I'll take log on both sides. What this will become? Now I'll take log 2. Why log 2? Because I want to remove this 2 as well. So I'll log 2 of n here, and I'll say this k. Right. So you can say that if we reduce it, can we not say that k is nothing but log 2 of n? And in log 2 of n step, we'll be able to reduce this number. So the time complexity will become log 2 of n. Similarly, if you try to do that with the multiplication part, if you try to do with multiplication part, the similar logic will be applied and the time complexity will come out to be this. Right, so this is it for today, and I hope everyone have got anything. And again, I'm saying sorry for the noise or the voice problem that happened. Right, and all these PPT and all these problems, you will get that in your in the description. From there you can get it. And if you have enjoyed anything, if you have got any new concept or something, do share it with your friend, do like the video, and you can subscribe to the channel as well. Right, we'll come again tomorrow at the same time with the better equipments for sure for the next time, and we'll look into the next topics. Right, chalo. So that is it for today, and good evening everyone, and have a nice day.